Yes, welcome back to our series. So in this video we are going to discuss how to make a traffic light controller using Arduino and few LEDs. So let's create a new project. I'll click on create new circuit. Yes, now let's rename this project as traffic light controller, which is our project 2, right? Yes. So that's we have done. Now I'll be selecting the components required for this project. So we'll be selecting Arduino Uno and few LEDs. This is Arduino Uno R3. Now let us select this LEDs required for this project. So from components basic, I can get this LED. So let me drag and drop 3 LEDs to your design workspace. Yes. So we just took 3 LEDs and let's change the colors. So since it's a traffic light, so the first LED I will make it green, and the second one can be orange or yellow, and the third one let it be red. That's it. Now let us complete our circuit. Here you can see for LED there is 2 terminals, cathode and anode, which we discussed earlier, right? So the cathode, as we know, we want to connect to ground, and the anode we want to connect to any of the digital terminal. That's it. Just to make this 3 cathode terminal we can connect to ground. We already have 3 ground pin. 2 ground pin at the bottom side of the Arduino and 1 is on the top side. That's sufficient. But if we have more than 3 LEDs, then what we will be doing? For that we just want to take an additional component that's called breadboard. You can search here in this basic component, we'll get this different configurations of breadboard. You can see breadboard small, breadboard mini, and even the Arduino is connected with the breadboard. So far I just took this breadboard small, I just kept it in the design workspace. Now let's see what this breadboard is all about. So this is the backside view of the breadboard. There are some metal strips are connected at the backside, at the bottom side, which is placed in different order. Okay, some metal strips are in horizontal way and some are placed in vertical way. Okay, so it's a simple plastic board and it is used for prototyping. If you want to make a simple temporary electronic circuit, instead of making the fixed soldering, we can use the breadboard and we can establish all these connections and reduce the number of wires used in this circuit design. That's a benefit of using a breadboard. But before going to use that, we just want to understand how it is configured and how it is manufactured. Okay. Now let's see this in detail. You can see here there is something there is a red line and blue line. Red line it's written plus, that's a power rail, and in blue line it is written minus, so that's the ground rail. Okay, what do you mean by this rail? Rail will help you if you are connecting any of the holes in the rail to the ground. Okay, the entire ground rail will become short circuited. So you can take the wiring, you can take the ground from anywhere in this blue line, and you can take the 5 volt anywhere from this red line. Okay, so this is about the ground rail and power rail. They're horizontally connected. But on the other hand, you can see in circuit area there are some strips, they are vertical. Okay, so that means to say in circuit area you have 2 vertical sessions. Okay, there is a gap in between, that's why I'm telling it's divided into 2 sessions, but they are vertically connected. If you are placing any of the component over here, you just want to make sure that you just want to keep this in mind that they are vertically connected. Now let's see how actually this breadboard will help us to make our electronic circuit. How we are going to connect our LED to this breadboard. So let's go back to our a design screen. Here you can see in this breadboard there are some lines, right? There is no particular red and blue line, but instead of that it is giving a hint. If I'm keeping my mouse over there at the bottom side, like in plus or minus, you can see it's giving the hint that it is horizontally connected. The power rail is horizontally connected and even the ground rail. Where it is written minus, there I am supposed to connect the ground. Where it is written plus, I am supposed to connect 5 volt over there. And the middle of this breadboard, which is our circuit area, you can see there is some vertical connections. Okay, if you have any doubt how it is connected, you can just keep your mouse over there, so it will be giving the hint. There will be a light, maybe green shaded straight line, that's it. Now let's keep our LED over there in the circuit area. So far you can see the cathode is in different strip and anode is in different metal strip, right? I have the option to rotate any of the electronic component. If I am rotating this LED completely to this 90-degree, you can see that the anode and cathode in the same metal strip, which mean to say they are internally connected. Internally they are short circuited. That shouldn't happen, right? So again, let me keep back my LED to the original position. This is the correct way of placing an LED in the breadboard. The cathode should be in different strip and anode has to be in the different strip. Okay, perfect. Now let me connect my cathode to the ground rail, right? Before that, I just want to establish the connection between this Arduino and the breadboard. I'll be connecting the Arduino ground to the ground terminal of the breadboard. Means where minus is written. So you can see there is a black line which is connected from ground to minus, and there is a red line which is connecting from plus 5 volt to the breadboard plus. And if I am using the opposite side of the breadboard, power rail and ground rail, I can make a short connection from here quickly. It's optional. If you are planning to use the upper side, then only you can make. And similarly, I will be connecting all LEDs cathode to the ground rail. It's very simple right now. I don't want to connect directly to the Arduino. I will keep directly this to the power rail or ground rail. Now here you can see I am just going to add the resistor. The resistor is having two terminal. Terminal 2 I connected to this LED's anode, and terminal 1 I will be connecting to any of the digital pin. But you can see, right, the resistor I placed at the middle of the breadboard. That means the resistor 2 end is not short circuited. There is a gap in between this two circuit area, upper and lower. Now from the bottom side of this resistor, that means from terminal 1 of the resistor, I will make a connection to digital pin 2. That's it. Now in similar way, the other two LEDs also I'll be connecting to digital pin 3 and 4 through a resistor. I'm using only 250 ohm since I'm expecting more brightness for the LEDs. Now let's start our block coding. So we are already in blocks, and since LED is an output block, I'm just clicking on output block, and from here I'm just taking the second block. It is set any digital pin high or low. So I just selected this block, I took it twice. The reason is that I have 3 LEDs, right? And the 3 LEDs are connected to 3 digital pin, different digital pin. So green is connected to 2, and this orange is connected to 3, and this red LED is connected to 4. As we know, at a time in traffic light there will be only one LED on. So in the first strip I will be making pin 2 high and other 2 low. It means to say only green LED is on. Then after a delay, again I am going to repeat the entire process. So I just duplicated this 4 blocks together and I attached it at the bottom. And once more I have to repeat the same process. So what I'll be doing, I'll be just detaching this code and duplicating it. Okay, now it's perfect. Now I will attach everything together. So in the first strip of code we just made green LEDs on, and in the second case we just made the orange is on, which is pin number 3 high. Then after a delay, now in the third process I'll be making like pin number 2 is low and pin number 3 is low and pin number 4 is high, where we connected the red LED. Now if you want, you can use the different delays. For example, here I'm making green is on for 3 seconds and this orange is on for 1 second, and the stop LED, that is red, is on for 2 seconds. That's it. Now let's test it. You can hide the code. So here you can see the green is on for 3 seconds, orange is quickly on off, that's only for 1 second, and the red is on for 2 seconds. So right now we made our perfect traffic light controller circuit using Arduino and 3 LEDs. Now in the next lesson we will be seeing how to control this entire traffic light controller using a push button switch. Okay, so let's continue that in this next lesson. Till then, take care, bye bye, thanks for watching.